we've got a bag of marbles that has 12 yellow, 3 blue, 1 red, and 4 orange. What is the probability of not selecting an orange marble? What do you think? Couple of ways you can go through this. What do you think?
0.8.
Genuinely haven't calculated it yet. You easily could be right. There we go. I knew all I had to do was start talking and they'd finally come and do it.
At this time, all freshmen need to
Yes.
proceed to the auditorium. All freshmen need to proceed to the auditorium. Bring your belongings. There will be dismissal from the auditorium. Again, all freshmen report to the auditorium. Teachers,
have
you need to
none
go with
freshmen
your
in here.
students. Teachers, you need to go with your students. If you have freshmen on the high school side in a mixed class, they can get there. Other teachers will supervise if they are only a few. If your class is majority freshmen on the high school side, you need to attend with them. Again, teachers, move your students quickly to the auditorium and get seated toward the front. There are no assigned seats. Get moving to the auditorium at this time. Thank you.
Okay. No, you are 2 doors down. I was gonna say, I didn't see you on my thing, but that doesn't mean it always showed you. I'm writing it over real quick. She's like my friend. There we go. Okay, I was gonna say, let me have the little pack of things. You don't need to choose. That's okay. Write it down. This goes- that's a lot of paper. The other ones I don't care, but this is a lot of paper. Alrighty. So it very easily could be that decimal that you shouted out. How would we get that? Because honestly, I haven't calculated it yet, so I don't know.
I added all
Yep.
the yellow, blue, and red together.
Yes.
A numerator, and then I added the 4 orange to it for my denominator.
And we did our 12 plus 3 plus 1 plus 4. Absolutely valid to do it this way and get that we have, let's see, 16 over 20. Yeah, I was just doing that real quick. Valid way to do so. Absolutely valid. Adding up the things that are not orange. Other option would be, or the other like fast option that I see would be to take, all right, I know orange is 4 out of the 20 marbles, and that means there's 16 left over that are not orange. Either way, that's fine. So to get this as a decimal, we can either simplify this to be over 10, which is my instinct to do, to go 8 over 10, which means our decimal is 0.8. Or our very bestest friends. We love them. They're our bestest friends. They have so many answers for us, as long as we know how to use them. Type it in the calculator. Totally fine. Valid strategy. Okay, number 2's from what I hear, the longest one on this one today. So we've got Jack has a new car, and he got a license plate that has 4 letters. So we want to know how many ways we can arrange 4 letters. I was like, and we haven't worded one quite like this before. I can see how we got 16 because we had 4 spots for letters. So I'm going to do a little thing. So if we have a license plate, 2, 3, 4, with 4 blank spots on it, and we know it's going to have letters in it. It's just a So here's my beauteous license plate with 4 letters. How many options do I have for this first spot? 26. There's 26 letters. How many options do I have for this spot? 26. How many options do I have for that spot? 26. And for the last spot? 26. So if I was to take all of these options and smash them together, what would we do to find out how many possible ways we could arrange 4 letters in a license plate? Not add, but good thought. Multiply them. This is fundamental counting principle. This is like the outfits thing, or the snacks, desserts, drinks, menus thing. I have 26 options for the first, or for my drink, 26 options for my snack, 26 options for my meat, 26 options for my dessert. I have a certain number of options, and to find out how many ways we could combine 4 letters together, we multiply them together. So for part A,
It didn't say just see that. That's why I got confused. It didn't
Yeah.
just say Jack, like arrange the letters.
Yeah.
CK. It was talking about all the letters.
all letters. Yeah, maybe up. No, I totally get that.
Wait, so the answer is
For part A,
4,
Yep.
6, 7, 9.
4, 5, 6, 9, 7, 6. Totally fine. 100%. When I'm doing this, you just holler out the numbers in order. That works for me. 456,976. Okay. So that's the how many arrangements. Looking at part B, which is a slightly different question. Part B says if he locks in that he's getting a 4-letter license plate, that's the only option they let him pick. It has 4 letters. What is the probability that by luck it says Jack?
1 out of 4.
1 out of how many possible options?
All of them.
All them. So if all he says is, I know my license plate's going to have 4 letters on it, because that is all they let me check the box for, he's got a 1 in 456,000 chance that it's going to, by luck, say Jack. 1 out of 456,976. Not putting that as a decimal. We're going to leave that as a fraction, and that's your answer. So our fundamental counting principle and even sometimes our permutation stuff can get used into probabilities. These are often going to become our denominators. But it's not going to be like a super common thing. Just looking at stuff I got. And then number 3 is the exact same one we did yesterday. So you already have it. Super fun.
973.
That is a 976. Better? I don't know. Now it looks like an upside down G.
I would just erase it and write it.
That means I have to be really good with the eraser to not get the fraction bar. There we go. There. Slightly less bad. Now it looks more 6-ish. Yeah, if you ever can't tell what I've written, please ask. I am more than happy to rewrite, re-explain, or genuinely change something that I've written. Totally fine. All right, so I know we filled this part out yesterday. I'm just going to real quick go through it because I know I've got some friends that either didn't get it written down because we were right at the end or for whatever reason. Also partly because all my other classes didn't get to this part, so I'm going to have to go through it with you. So you should have a lot of these things written down, so I'm not going to go super slow on this. We've got that our combination is a way. Oh, sorry, this is on page 7. Page 7. I put it up in the corner over there. And it's like the second line. We are not doing that top line. I hate that problem a lot. Okay, so combination is a way of grouping elements into subsets where order I don't know why I did that as a capital, but whatever. Does not matter. was like, we did write this yesterday, so you may have this written down. Cool. Where order does not matter. And our notation for this is very, very similar. We have our n in front. And this is our total number to pick from. So if there's 50 people in the race, there's 26 letters, there's 12 mules. Total number of things to pick from. And we are going to be picking, drawing names out of a hat with our R. R comes at the back, and it's the number of objects or people. We just use objects as, that's not how we spell object. Still looks wrong, but whatever, close enough. Objects we pick. The ones we're looking to select. Okay, so then I'm going to give us our formula, and I have two ways of writing the formula. One of them is completely independent. One of them relies on our permutation formula. So the one we're going to use today on our practice problem is going to be our n factorial over n minus r factorial. That should be very familiar. But in the denominator on this one, we also have another r factorial. So we got 3 factorials in this one instead of just 2. The other way you can think about this is to calculate the NPR and then divide by r factorial. You can do it either way. Either way is fine. And what we're going to do is we are going to do a practice problem for combination. And then we'll finish out this page. But the question that's right below what we just wrote is not actually a combination problem. It's a fundamental accounting principle. So it's in the wrong spot. So what I have here is a replacement problem. Every set of tables has a box on it. In that box are some glue sticks. Glue this in on top of that marble bag problem that's right there. So this is the problem. I'm going to pass these out. You shouldn't need to cut them. There are scissors in there in case you're like super picky about how things are cut. You shouldn't need to cut it. If you cut it, you got to throw your own scraps away. Please don't make me clean up your scraps. But in the box that's on the table, there are at least 2 glue sticks. So we're just going to glue this over that problem with the marble. We do have to share. I'm playing nice.
Yeah.
It's just like 3 seconds breathe. We share. If your glue stick doesn't work or is dead because I didn't test all the glue sticks, please let me know. Thanks. So if your glue stick doesn't work, just let me know. I have a literal bucket of them. I just wasn't tossing all of them out. And I wasn't going to sit here and test 30 glue sticks. Yes, dear. Is that one dead? Okay. Grab spares. Y'all are my first people to glue things this year. So working on it. Where's that? I got more. Good. All right. Should be good ones. You did? You did one? Yep. Again, not surprised. A lot of these are left over from last week.
Where do you do that, Mom? You never at home, like ever. I swear to God, I didn't know that road.
Oh, look at Trushy. Look at Trushy.
Or the stove, or like, I don't know where you get it. You just be out the crib. The other day, you wasn't even in that. You was in somewhere else, having it.
Okay, that's a hike. Why is there a business?
I don't know, that's just, it just
Like, you're nosier than I am, man.
Oh, what I saw yesterday, French fly?
And I eavesdrop on everything, and you nosier than I am.
French fly?
All right.
That's my last. That was my last verse. I mean, my last set.
So, we're going to talk through this problem. I know some of you guys are probably still gluing. That's okay. This problem, as we can tell by the fact that we just glued it in, is going to be combination, because if we have to do that much work, definitely going to fit the spot. But let's talk about why. Okay, so it says, suppose you are, so we're packing for vacation, and you want to take 3 hats. You own 7 hats. So you're going to pick out your 3 hats to take. And we've got some pictures down here at the bottom that might kind of help see what's going on. Kind of. They're really small and very clip-arty, so I made them very small. But if I pick my baseball hat, my formal wear, and my fedora, it doesn't matter if I pick my baseball hat first or if I pick my baseball hat last. It's still coming with me. It doesn't matter if it's first, second, or third. It's not like if I pick it first, it gets the gold medal. And if I pick it last, it gets the bronze medal. It doesn't matter. They're all coming on the trip. So it does not matter what order they are picked from. So that's what we mean when we see order doesn't matter. Order matters is first, second, third in a race. It matters who's in which spot. Combination is they're all coming to the picnic anyway. It doesn't matter. So the way we're going to write this is we're going to do it the very same way we did permutations yesterday, except the only difference is it's a C in the middle instead of a P. So we're going to put our number of things we pick from. How many total things do we have to pick from? 7. We're doing a combination because order is not important. And how many are we choosing? 3. So 7 choosing 3. And I tend to write it like this. If you do them all in the same line, totally fine. So I'm going to use that formula that we just wrote down for us to calculate this out. So we're going to have our fraction. We take our n, which is the front number, and that goes on the top. So we're going to have our 7 factorial. Then we do our n minus our r, which is 3 factorial. And outside that, we're going to put another 3 factorial. So it's a little bit more complicated. A little bit more complicated. We're still going to simplify it in kind of the same vibe. I'm going to keep my numerator. I'm going to write this in a couple of steps. So I'm going to leave my 7 factorial up here. I'm going to simplify my parentheses. 7 minus 3 is going to give me what? 4 factorial. And then we also have our 3 factorial. So a little grosser. I'm still going to be able to simplify just like we did yesterday. A little. Not as much though. So we're definitely going to want to be able to do things on the calculator with this one. So I'm going to take my 7 and write it out until I get to the bigger one down here. So I'm going to write it out till 4. So we're going to have 7 times 6 times 5 times 4 factorial. I'm just going to stop there and not write the whole thing out. Because that's going to leave me with 4 factorial, 3 factorial. And what's going to happen with my 4 factorials? They're going to cancel out. So better-ish. So on the top, we now have 7 times 6 times 5, and on the bottom, we have 3 factorial. 3 factorial being 3 times 2 times 1. Am I hearing music? Or is it just a chair squeaking rhythmically? I think we're just wiggling rhythmically. All right, so I've got my 7 times 6 times 5, and on the bottom we have our 3 factorial. You can either put it in your calculator with the exclamation point. Almost every calculator has one. Or you can do our 3 times 2 times 1. So do this. What do we get? How many different combinations of our 7 hats could we pack? Yeah. Why don't you guys finish it? 35. You can type it in the calculator, and you can either do 7 times 6 times 5 on the top, 3 times 2 times 1 on the bottom, and then simplify. Some of us might notice that, well, 3 times 2 is, in fact, 6, and then the 6's cancels out. We can do 35. No matter what we do, if we type it in up here, over there, down here, wherever we type it in, we should wind up at 35. Yes, my dear? It will not say whether it's a permutation or combination. That's going to be what we're going to do next. We're going to practice telling when is going to be which. Okay? That's what the last 3 are on the page down here. Just because 4 is trash. Okay. Questions on this as it stands right now? So we're going to look at those bottom 3.5 questions. We'll look at 4, but, and we're going to decide whether it's permutation or combination. We're going to write it in our notation, and then I'm going to show you the calculator shortcut. Here you don't have to factorial at each time. Because I found out we can use our calculator shortcut because it should be on the SAT calculator from what I've been told. They're upgrading it, which should have the button, so I can show you the button. Means I need to open the button. All right, so this is the list that's down below. And I know my wording on team 1 is a little bit different than yours. Mine's clearer. So we've got a team of 8 basketball players, need to choose 2 co-captains. How many people are we choosing from? 8. How many people are we choosing? 2. So we've got our numbers, easy peasy. Now we're going to figure out, does it matter what order they're picked in? Or does it not matter what order they're picked in? It does not matter. Why? Because it's 2 co-captains. I could swap them around and they're still the same 2 co-captains. So that means this is which one? Permutation or combination? Combination. Order does not matter. So this we would write as 8 combination choosing 2. Okay? So this is a combination. I'll write the combination word out. We're going to calculate them all at the end because I'll have to go back and forth to my calculator. So we're going to write them in notation first. So then we're doing the batting order for a 12-person baseball team. How many people are we choosing from? 12. How many people do we choose? It doesn't say. In general, when people play baseball, who gets to hit the ball? Doesn't everybody get a turn?
Yes.
So if we have 12 people on the team, how many people need to be in the batting order? 12. So we have 12 choosing 12. The numbers can be the same. If we're choosing the batting order, is order important?
Yes.
Yes. So is this a permutation or a combination? Permutation. So if it has the word, like if order is important, and this one is straight up called a batting order, I'm assuming order is important. My sports skills are super awesome. I played softball for 2 years for my church, and I earned my way onto base a grand total of twice in 2 years. I'm good at sports. It's like that is like the highest level of sportsing I've done. Just saying. All right, so we have 12 people. Order is important, so we're using our permutation, and we're choosing 12 people. This is our permutation. Love that. Boop, boop. There we go. All better. My iPad and my screen like to have fights with each other every now and then, and they just will change the page because they're in a mood. All right, bottom one says there's 45 applicants for 3 computer programmer positions. What do we think? Combination. Because does it matter who's picked first, second, or third? No. So we've got our combination. How many people are we choosing from?
45.
45. And how many are we choosing? 3. Okay. I'm going to show you the calculator way to do this so we don't have to do as many factorials, since they told us that it should, when they update the SAT, they should have the calculator button. So we are going to do our 8 choosing 2, starting up with number 1. On the yellow calculators, this is exactly the same as this. I'm going to put in my 8, putting in my N. I'm going to hit that PRB button. And now that we know what these are, look, I have permutation, I have combination. And we said that this first one was combination, so I'm going to hit the 2 right there. And we were choosing 2 things. 8, choosing 2. It even reminds you which sides N and which sides R. I will. And that gives us our 28. If you do it with the factorials, it absolutely gives you the same answer. So I'm just writing it down. 28. Boop, going back. That one was combination. And if you look down here on the calculator screen, I keep it up here so it shows you exactly which buttons I pressed. So we did 8 PRB. I went down to get to number 2, hit enter, and then. So our next one was our permutation where the order matters. So we had 12. We're doing our PRB button. This one was a permutation, so it's that first one. And then we were choosing 12 things. Okay? Big number. Some of these will be very, very similar. Like
calculator, but it's a probability right there. You see that piece?
I would say a lot. I'm going to say not as many of the scientific calculators have these buttons. Everything will have the factorial button, but most will have these, scientific-wise. Not all, though. So it's a little less common. But I do believe if you use the Desmos calculator, like on your phone, it should have that. I don't think the iPhone calculator has it, but I haven't looked in a minute. But so this is our answer for number 2. That's the different ways you can arrange the baseball team. 479,001,600. Why your coach gets grumpy if you don't show up to the game, it messes with the batting order. They had to choose from 479 million options. All right, the last one. See if you can do it. Type it in your calculators. I have bazillions. I'm not going to do the exit today. It's not going to happen. I don't have time. Not a do you. Grab the calculator, see what you can do. Looking to see if I want to pass this out today. I don't want to pass this out today. I'm going to give you this one. Decision made. I'm not passing that out today. So what do we get for the last one? I want you to try and type it in. Yes. You should get 14,190. So you've done it the hard way. Now I'm showing you the easy way. Okay? But we had a meeting yesterday, and they're like, "Brooke, didn't get a SAT calculator." I'm like, "Oh, great. I already showed them the hard way." Better that than them going, "Ha, you don't get to have that now." Okay, so we should be better on our combinations now. Not giving you guys homework 3 yet. I'm going to pass back homework 1 so that you guys have that. The grades that should be in. Before you throw these away, please make sure it shows up on the Canvas gradebook. It should also have ported over to Skyward, I think. I need to check that. That's part of what this is making sure all my stuff talks to each other the way it's supposed to. But it should be in the Canvas gradebook for sure. So I'm going to pass these back. That is it for today. But this is also how I start learning y'all's names. So. Oh, that's why that doesn't match. I put that on the wrong
Look, I got a sticker.
They literally came off the same sheet. We ain't gonna do competitions on the stickers. I'll buy enough stickers for that kind of problems. I have like 3 different sticker sheets that I can put fresh.
You always give us stickers?
If it's 10 on 10.
Oh.
Announcements. I'm so good at doing announcements right on time. Yeah.
What you got?
Done.
I ain't on it. That's technically, I don't know. See, I just ain't gonna take physics. This is my last year. Yeah, I don't want physics.
They were not here. Sweet. I love that. So much fun. I will also put up on the wall over here, over there, the answer key for homework 1. So if you want to check the rest of yours, I only checked a couple of questions. If it's got a red check mark next to it, it was correct. If it has an X, that particular question was wrong. I only checked the ones that were marked. So I did not check every question. I don't got time to grade every question on every homework. So I will also scan this probably and get it up on the Canvas page, but I have it over here so that you can check your work, okay? But I will post it on the Canvas page because we also have like 3 minutes till the bell.